All right, peeps, here we go with learning target number 3, sunspots and solar irradiance. We're looking for just the use of 2 keywords here, temperature and solar irradiance. And reminder to you, solar irradiance essentially means sun's energy. So again, we're breaking it down into 3 parts. Number 1, what is it? What do we know? Number 2, impact to climate. And then number 3, our because, right? Our evidence that that's occurring. So I'm going to go back to the slides and give you kind of an outline, and you can be filling in your learning targets as we go. So again, sunspots, number 1, what do we know, right? What are they? Well, essentially, we know the sun is doing 2 things. It has a solar irradiance, right? It's giving off energy. And we also know it has these periods of sunspots. And we did talk about the sunspots being cool pockets across the sun's surface. So when you're filling in your number 1, we just want to know that the sun has both of those characteristics. It gives off energy, and it has these cool sunspots. And both the sun's energy and the sunspots go in cycles, right? They both cycle times of high and low throughout the course of time. That's our number 1. Our number 2 then is, well, what is the connection to climate? Because sunspots are cool, we have kind of a perceived idea on what they might do to the sun's energy. So here, this blue line is looking at levels of sunspots on the sun over time. So we can see all these Januaries of different years being measured. So here we see a decrease in sunspots, an increase, a decrease. So that's the cycle that we were talking about. And then here, the red is our sun's energy or solar irradiance. And so what we're noticing here is anytime we have a dip in sunspots, we also have a dip in the sun's energy output. If we have an increase in sunspots, we have a rise in the sun's energy output, and so on, which is tricky because that seems incorrect, right? We talked about how sunspots were areas of cooling. So your brain probably went, okay, when there's more cool spots, the sun's energy level is going to go down. But we don't see that in the graph. We see that when sunspots go down, solar energy also goes down. They follow each other on the graph. And so that's a little irregular. And so when we put all that data together, we can then figure out, well, does the sun's energy have an impact on global temperatures? Here, before 1950, we can see when sun's energy goes up, so do global temperatures. So the graph shows the data pretty much together. After 1950, when we see solar irradiance dropping back to prior levels, we see the Earth's temperature still continue to increase. The data starts to trend apart. And that's different. And so here's what we're thinking about with our solar irradiance and impact to temperature. Our number 2 is essentially there is no connection between that solar irradiance. I'm going to abbreviate with my space here, but you can be writing it out. No connection between solar irradiance and global temps. There isn't an impact to climate. We don't see a consistent trend with these 2. And again, our number 3, we have to explain it out, is the because. This right here is your because. Because when solar irradiance drop, temperature continues to increase. There is no direct connection between the sun's energy output and our global temperatures. That's what we're looking at here. Because when, what the data says, solar energy drops, Earth's temperatures continue to increase. We cannot use solar irradiance to explain the current trend of warming happening here on Earth.